Particle size distribution, or the percentage of grains of different sizes in a given soil, is an important property of soil. Particle size analysis of coarse soils is carried out by sieve analysis or mechanical analysis, whereas fine-grained soils are analyzed by hydrometer analysis. In general, a combined analysis is carried out as most soils contain both coarse and fine particles. In the combined analysis, dry soil is first analyzed by sieving, and then the very fine soil is analyzed by hydrometer or pipette method by mixing it with water. Importance of particle size distribution. Particle size distribution is important for classification of soil. It is also used for the design of drainage filters. It is used for selecting filling materials for embankment, earthen dams, road sub-base etc. Particle size distribution is also used to estimate performance of grouting chemical injection. Mechanical sieve analysis as per IS code IS 2720, Part 4 1985. Sieves are wire screens having square opening. According to IS 460-1962, the sieve number is the mesh width expressed in for large sizes and in microns for small sizes. The 4.75 mm sieve separates the soil into two parts. The fraction larger than 4.75 mm is called as coarse fraction. This fraction is analyzed by the following series of sieves: 100 mm, 63 mm, 20 mm, 10 mm and 4.75 mm sieves. The sieves are arranged in descending sizes from top to bottom. A weighed, dry soil sample is put onto the top sieve. Generally 1000 gm sample is analyzed. The top sieve is covered with lead and the bottom sieve has a pan below it. The entire assembly is then shaken either manually with careful up-down and circular motion or in a machine known as sieve shaker. Usually 10 minutes of shaking is sufficient. The soil retained on each sieve is then weighed and the weight is recorded. The soil collected in the pan is subjected to further analysis. For this, a series of 4.75 mm, 2.4 mm, 1.2 mm, 600 microns, 425 micro, 300 micro, 150 micro, and 75 micro sieves is used. These sieves are arranged and the sample from the pan is shaken for another 10 minutes. The weight of soil retained on each sieve is then recorded. The soil particles passing through the 75 micro sieve are collected in the pan. If the amount is significant, it is mixed with water for hydrometer or pipette analysis. A table is prepared, in which percentage finer and cumulative percentage finer particles corresponding to each sieve size are worked out and plotted on a semi-log graph paper. Particle size distribution curve. As said earlier, the cumulative percentage of a particular size of particles passing through that size of sieve opening is worked out. It is plotted against the size in log scale. It is drawn semi-log graph paper, because the particle size may range from a few microns to a few hundred Hence, on ordinary scale, a very long graph paper would be required, which would be impractical. Thus, cumulative percentage finer than, or cumulative percentage passing through, is plotted on y-axis in natural scale and the corresponding sieve sizes are plotted on x-axis in logarithmic scale. The resulting graph is known as particle size distribution curve. This curve forms one of the important index properties of the soil. Above diagram shows typical particle size distribution curve for well-graded, uniformly graded and gap-graded soils.